Today I'm talking about another coordinate system. This is circular cylindrical coordinate. We have already discussed about rectangular coordinate system. For shape with circular type in xy plane or a type of symmetry, other coordinate system, at this time this is cylindrical coordinate, is more convenient to use rather than rectangular coordinate. How does the point describe in cylindrical coordinate system? In cylindrical coordinate system, rho, pi, z, these three parameters characterize cylindrical coordinate. I will explain this comparing with rectangular coordinate system. Rectangular coordinate system describe the point at x, y, z. Point P is x, y, z, and projection of point P on xy plane is q, x, y, 0. This is x, this is y, and this is z. Rectangular coordinate make rectangular parallelepiped like this. This is a rectangular cylindrical coordinate. The point is described rho pi z. This is the y-axis, this is the x-axis, this is the axis. Cylindrical coordinate make a cylinder. I will draw the part of cylinder like this. This is part of cylinder. And point P can be described rho 1, pi 1, z1. The projection of P on xy plane is q is rho, pi, 0. The rho is distance from origin to xy plane projection of P. Xy plane projection of P is q. So rho is distance from origin to q. This is rho. And pi is angle from x-axis to q in counterclockwise. This is pi 1. And z is height from q to p. This is z. The point P in cylindrical coordinate is described intersection of rho is rho 1 constant plane, pi equal pi 1 constant plane, and z equals g1 constant plane. Rho equal rho 1 constant plane is yellow plane. Yellow plane is constant rho 1 plane. This plane, yellow plane is rho equal rho 1 constant plane. And pi equal pi 1 plane is green plane. This green plane is this plane. This plane is pi equal pi 1 plane, and z equals z1 constant plane is sky blue color plane. This is z equals z1 plane. So this plane is z equals z1 constant plane, and yellow plane is rho equal rho 1 constant plane, and the green plane is pi equal pi 1 constant plane. So intersection of these three planes is P. So point P in cylindrical coordinate is intersection of these three planes. How about unit vector of cylindrical coordinate? Unit vector in cylindrical coordinate is a rho vector, a pi vector, a z vector. So we draw cylindrical coordinate again. This is y, x, z. I will draw the part of cylinder. part of cylinder like this. This is part of cylinder, and this is P, rho, pi, rho, pi, z, and projection of P on xy plane is Q, rho, pi, 0. The yellow plane is constant rho plane, rho equal rho 1 plane. This is rho equal rho 1 plane. And green plane is pi equal pi 1 plane. Green plane is pi equal pi 1 plane. This is pi equal pi 1. And sky blue plane is z equals z1 plane. Z equals z1. So a row vector is unit vector is directed outward from P. This P is normal to plane constant low plane. This unit vector is perpendicular to constant low plane. A row vector and perpendicular to constant low plane. And a pi vector is unit vector is directed from P to normal to constant pi plane. This green plane is constant pi plane, and this is a pi vector. It's perpendicular to constant pi plane. And AZ is unit vector is directed from P to normal plane z equals z1. So this is a row vector. This unit vector is a pi vector. This unit vector is a z vector. So these three unit vector characterize cylindrical coordinate, and these three vectors are perpendicular each other, like this. What is the dot product and cross product of these unit vector? And the same as a rectangular coordinate, the dot product of same unit vector is 1, and dot product of different unit vector is 0. Is the same as rectangular coordinate. Cross product in cylindrical coordinate is same as also rectangular coordinate. A row cross a row, and a pi cross a pi, and az cross az. Cross product of same unit vector is 0 vector. Cross product of other unit vector is another unit vector. A pi vector cross a row vector cross a pi vector is a z vector. A pi vector cross a z vector equal a row vector. A z vector cross a row vector is a pi vector. So a pi vector. A pi vector cross a row vector is minus a z vector. A z vector cross a pi vector is minus a row vector. A row vector cross a z vector is minus a pi vector. This is the dot product and cross product in cylindrical coordinate. Next is differential area and volume. Cylindrical coordinate make a cylinder. Differential volume and area volume is cylinder volume. So we draw again part of cylinder. Y, X, Z equals 0. We can draw part of cylinder like this. The cylinder. This cylinder volume consists of 0, and rho d phi and dz. Dz is this is the dz, and rho d phi and 0. This volume is differential volume of cylinder. This is 0 and rho d phi, because this is the d phi and this length of curve is rho d phi. So this is rho d phi and rho d phi, 0 and dz. This is dz. This is the volume of cylinder. So, but this is not rectangular parallelepiped, because rho d phi is not line. This is a curve, but d phi is too small. We approximate this curve, rho d phi, approximated line, rho d phi. So this volume can be approximated rectangular parallelepiped, like this is. And this is a rho direction, and rho d phi and dz and 0. This is a phi direction, this is az direction. So we try to find surface area. As rho is surface area in rho direction, it means the surface is perpendicular to a rho vector. So we draw again. The approximated rectangular parallelepiped this, and rho d rho and d z d rho, and this is direction of a rho vector. So the perpendicular surface to a rho vector is this bottom surface and top surface. So this is a rho vector. Vector is perpendicular to bottom and top surface. The area of bottom and top surface is rho d pi multiplied dg, rho d pi multiplied dz. How about s pi? S pi is surface area in pi direction. We draw again. Where you can draw like this. Pi direction is this direction. Rho d phi dz 0. So perpendicular to a pi vector is green surface, right surface, and left surface. The area of right surface and left surface is 0 multiplied dz. This is a surface area in pi direction. Surface area in g direction is, we draw again. we draw again like this. AZ vector is this vector. Perpendicular to AZ is front plane and back plane. This is front plane and back plane is perpendicular to AZ vector. So this is rho d phi, d rho dz. So surface area of front plane and back plane is rho d phi and d rho multiplied rho d phi. This is surface area, and volume is rho multiply rho d rho multiply rho d phi multiply dz. This is volume. So d rho and rho d phi and dz. This is differential volume in cylindrical coordinate. So next topic is point transformation. This is point in rectangular coordinate can be transformed the point in the cylindrical coordinate. The point in cylindrical coordinate can transform rectangular coordinate. This is point transformation. The variables of rectangular and cylindrical coordinate system are easily related to each other. We have two cases. First case is rectangular coordinate is given and find the point cylindrical coordinate. And we have already know x, y, z. We draw the three-dimensional rectangular coordinate is y, x, z, and we have already known px, y, z. So q is projection of p on xy plane. This is q x, y, 0. This is x, this is y, this is z. So we have to find rho pi z, have rho pi z. So this triangle is y and rho. We have already known x and y. So rho is square root x squared plus y squared. And tangent pi is y over x. So pi is arctangent y over x. Z equals z, right? Z in cylindrical coordinate is same as z in rectangular coordinate. So we can transform point P in the rectangular coordinate, change the point in the cylindrical coordinate. And second case is the point in cylindrical coordinate is given, Z is given, and we try to find a point in rectangular coordinate. So we have already known rho pi z, and we find x, y, z. So we draw cylindrical coordinate and y, x, z. We have already known rho pi z. And the projection of P on xy plane is q and rho pi, 0. We have already known this rho pi z, and we have to find x, y, z. z equals same, we have to find x and y. This triangle is this, and pi, x, y, and rho. X is rho cosine pi, y equals rho sine pi, z equals z. So we can transform the point in the cylindrical coordinate to the point in rectangular coordinate like this. Next topic is vector component transformation. We express a vector in rectangular coordinate or cylindrical coordinate. We have also two cases. First case is the vector in rectangular coordinate is given. In other words, a vector is ax vector plus ay vector plus az vector. We have already known ax, ay, and az. So we try to find a rho, a pi, az. So let's find a rho. A rho is rho component of a vector. This is a rho. A vector is ax vector plus ay vector plus az vector dot a rho vector. This is a vector ax multiply ax vector dot a rho vector plus ay multiply ay vector dot a rho vector plus az multiply az vector dot a rho vector. Since az vector dot a rho vector is 0 because these two vector is perpendicular, so this is 0. And we have to find ax vector dot a rho vector and ay vector dot a rho vector. This is ax vector, ay vector, az vector, and a rho vector is this vector, a pi vector, and this vector. So the angle between ax vector and a rho vector is pi. The angle between ax vector and ay vector is pi over 2, perpendicular. And angle between a rho vector and a pi vector is pi over 2. So we find ax vector that a rho vector is magnitude of ax vector multiply magnitude of a rho vector cosine pi. The pi is angle between ax vector and a rho vector is pi. The magnitude of unit vector is 1, so this is cosine pi. And ay vector dot a rho vector is magnitude of ay vector multiply magnitude of a rho vector cosine pi. The pi is angle between ay vector and a rho vector. Angle between ay vector and a rho vector is pi over 2 minus pi, because this is pi over 2, this is pi. This is pi over 2 minus pi. So this is cosine pi over 2 minus pi is sine pi. So a rho vector is ax cosine pi and ay sine pi. So how about a pi vector? A pi vector is a pi component is pi component of a vector. A vector is ax vector plus ay vector plus az vector. This is az vector dot a pi vector. Calculating this, ax multiply ax vector dot a pi vector plus ay multiply ay vector dot a pi vector plus az multiply az vector dot a pi vector. So az vector dot a pi vector is 0 because the angle of az vector and a pi vector is pi over 2. So we have to find ax vector dot a pi vector and ay vector dot a pi vector. So we draw again. This is ax vector and this is AY vector. AY vector is this. This is AZ vector. And A row vector is this vector. And A pi vector and this vector. The angle between AX and A row is pi. This is pi. Angle between AX vector and AY vector is pi over 2, perpendicular. And angle between A row vector and A pi vector is pi over 2. So we try to find AX vector that A pi vector is magnitude of AX vector multiply magnitude of A pi vector cosine pi. Pi is angle between AX vector and A pi vector is pi. So this no. AX vector and A pi vector this is pi over 2 plus pi. So this is pi. So this is cosine pi over 2 plus pi is minus sine pi. And AY vector dot A pi vector is magnitude of AY vector multiply magnitude of A pi vector cosine pi. The pi is angle between AY vector and A pi vector is pi, so this is cosine pi. So pi component of A vector is minus AX sine pi and AX cosine pi. AZ is AZ. The component is the same in rectangular coordinate and cylindrical coordinate. The second case is we have already known A row A pi AZ. In other words, A vector is A row vector plus A pi vector plus AZ vector is given. We have to find AX AY AZ. So we try to find AX. AX is X component of A vector. This is A row vector plus A pi vector plus AZ vector dot AX vector. Calculating this, A row vector dot AX vector plus A pi multiply A pi vector multiply A pi vector dot AX vector plus AZ multiply AZ vector dot AX vector. Since the AZ vector and AX vector is perpendicular, this dot product is 0, and we have to find A row vector dot AX vector and A pi vector dot AX vector. So we draw again AX vector AY vector and AZ vector. And A row vector is this vector. And A pi vector is this vector. So the angle between AX vector and A row vector is pi. Angle between AX vector and AY vector is perpendicular, pi over 2. Similarly, angle between A row vector and A pi vector is perpendicular. So A row vector dot AX vector is magnitude of A row vector multiply magnitude of AX vector and cosine pi. Pi is angle between A row vector and AX vector. This is pi. So this is cosine pi. A pi vector dot AX vector is magnitude of A pi vector multiply magnitude of AX vector cosine pi. Pi is angle of A pi vector and AX vector. A pi vector and AX vector is pi over 2 plus pi. This is minus sine pi. So AX is A row cosine pi minus A pi sine pi. We try to find AY vector. AY component, not AY vector. AY component is y component of A vector. The A vector is A rho vector plus A pi vector plus AZ vector dot AY vector. A rho multiply A rho dot AY plus A pi multiply A pi dot AY plus AZ multiply AZ dot AY. Since the AG vector and angle of AG vector and AY vector is pi over 2, AG vector dot AY vector is 0. So we have to find A rho vector dot AY vector and A pi vector dot AY vector. So we draw again. This is AX vector. This is AY vector. This is AZ vector. And this is A rho vector. This is A pi vector. The angle between AX vector and A rho vector is pi. The angle between AX vector and AY vector is perpendicular, pi over 2. And the angle between A rho vector and A pi vector is pi over 2, perpendicular. So we try to find A rho vector dot AY vector. It's the magnitude of A rho vector multiply magnitude of AY vector cosine pi. Pi is angle between A rho vector and AY vector. This angle is pi over 2 minus pi. So pi over 2 minus pi. This is sine pi. And A pi vector dot AY vector is magnitude of A pi vector magnitude of AY vector cosine pi. Pi is the angle between A pi vector and AY vector. This is pi. That's a cosine pi. So y component of A vector is A rho sine pi and A pi cosine pi. So AZ component in rectangular coordinate is same as AZ component in cylindrical coordinate. This is vector transformation from rectangular coordinate to cylindrical coordinate and vice versa. So we take an example. Transform B vector into vector in cylindrical coordinate. This is a vector in rectangular coordinate. This is a vector transformation, right? So the B vector is A rho vector plus A pi vector plus AZ vector. So we have to find A rho A pi AZ. We use the formula, and A rho is y cosine pi minus x sine pi. So this is a cylindrical coordinate. X and y doesn't exist. We have transform x and y into rho and pi. So x equals rho cosine pi, y equals rho sine pi. Substitute this value on A rho. This is rho sine pi cosine pi minus rho sine pi cosine pi equals 0. A pi component is minus y sine pi minus x cosine pi, right? Because A rho is ax cosine pi, ay sine pi. Ax is this is ax, ay, ad. So ax cosine pi plus ay sine pi, and this is minus y sine pi x cosine pi. So this is minus rho sine square pi minus rho cosine square pi. This is minus rho. And AZ is C, the same as rectangular coordinate. So B vector in cylindrical coordinate is minus rho A pi plus Z A Z vector. This is the answer of question 1. This question. And next question is find the rectangular coordinate point of this is the point in cylindrical coordinate. This is point transformation. So x equal rho cosine pi, and the rho is 4.4 multiply cosine 115 degree. Y equal rho sine pi, and 4.4 multiply sine 115 degree. Z equal 2. This is point in rectangular coordinate. Approximation minus 1.86. This is approximate minus 3.99. So point P in rectangular coordinate is minus 1.86, comma minus 3.99, comma 2. This is point in rectangular coordinate. And next question is vice versa in above question. Point transformation from rectangular coordinate to cylindrical coordinate. So we have to find the rho pi z. Rho is square root x squared plus y squared. Square root minus 3.1 squared plus 2.6 squared plus minus 3 squared. This is approximated 4.05. The arc tangent y over x. Y is 2.6 minus 3.1. So this is x equal 2.6, y equal minus 3.1, and no, this x is minus 3.1. This is wrong. X is minus 3.1, y equal 2.6. So this angle is pi. So the pi is between pi over 2 and pi. Pi is between 90 degree and 180 degree. So this approximates minus 114.01 degree, and z equal minus 3. The same as rectangular coordinate. This is the answer of this question. Next question is find the cylindrical coordinate vector of this vector. This is the vector of transformation at 10, minus 8, 6. This point is in rectangular coordinate. So this is x, this is y, this is z. Right? So f vector can be expressed a rho vector, right, plus ay, a pi vector, plus az vector at point 10, minus 8, 6. So a rho, the point transformation is square root 10 squared plus minus 8 squared. Pi is, this is rho, pi is arc tangent, minus 8 over 10, 6. This is point in cylindrical coordinate. A rho is 10, this is ax, ay, this is az. So a rho is, yes, 10 cosine pi, right, minus 8 sine pi, right. The pi is arctangent minus 8 over 10. It means y equal minus 8, x equal 10. Angle is this angle, minus 38, 8.66 degree. And this is 10 cosine minus 38.66 degree minus 8 sine minus 38.66 degree, and approximated 2.86 2.811, right? A pi is minus 10 sine minus 86.66 degree and minus a cosine minus 38.66 degree. This approximates 0. AZ equals 6. So F vector in cylindrical coordinate is 2.811 A vector plus 6 AZ vector. This is the answer of this question. And next question is rectangular coordinate vector and A vector is in cylindrical coordinate at point 5.2.1. This is rectangular at the point in rectangular coordinate. So A vector can be expressed by AX vector plus AY vector plus AZ vector. This is AZ vector. So we have to find AX, AY, AZ. AX is X component of A vector. This is calculus 20 A row vector dot AX vector minus 10 AY vector. No, this is A pi vector AX vector. We're calculating this, and this is 20 cosine pi plus 10 sine pi. We can find the pi in the point in rectangular coordinate. Pi equals arctangent 2/5, and this is approximately 21.8 degree. So this is 20 multiplied cosine 21.8 degree plus 10 multiplied sine 21.8 degree. So this is 22.28. So AY is Y component of A vector is Y component of A vector is 20 A row AY, A row vector dot AY vector minus 10 A pi vector dot AY vector. We're calculating this 20 sine 21.8 degree minus 10 cosine 21.8 degree is minus 1.856 approximate. And AZ in rectangular coordinate is same as AG in cylindrical coordinate. So this is the same, so 3, right? This 3. So vector A in rectangular coordinate is A vector is X component is 22.28 AX minus 1.856 AY plus 3 AZ. This is A vector in rectangular coordinate. So today we're talking about cylindrical coordinate and point transformation between rectangular coordinate and cylindrical coordinate, and the vector transformation between rectangular coordinate and cylindrical coordinate. Thanks for watching this video, and see you next time. Bye bye.